So now I want to talk about IUPAC nomenclature, and this is where it goes from super necessary to now it's starting to be annoying as well as necessary. And that's because there's a lot of details you have to get right if you want to get the IUPAC name right. And fundamentally, you can talk about molecules without knowing how to do the IUPAC naming. Having said that, the reason why you've got these crazy acronyms and is an organizing body decided to standardize all the nomenclature things so that now chemists across the world could interact with each other and call things by the same thing and make sure that they're getting it right. So there's one more piece of prefixes that we need to throw in there, and that is, given the number of substituents bound to a given molecule, we want to be able to refer to it. And so it's going to be a mono substituted, one thing on there, or di substituted, or tri. Obviously this is 1, 2, 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, deca for 10, although you really are going to tend to be living up here. So this molecule right here is obviously going to be a trinitro something, or alternatively, if you were thinking about how many methyls there are, you would say it's a monomethyl, although obviously you never really need to say mono, you just say methyl. So this would be a trinitro methyl sort of thing. Okay, so if you're trying to do nomenclature, the fundamental reality of IUPAC nomenclature is there's an algorithm, and you can learn it. It's in your book, and basically what you need to do is identify the base molecule that you're looking at, and in the case where you have a straight chain molecule like this, then what you're really trying to do is figure out what the longest chain is. So if I'm looking at this molecule, and I'm trying to size it up, one thing that might jump out at me is the presence of this sort of isopropyl group. And so you might say, oh, well, this could be a 1, 2, 3, 4 butane that has a chlorine and an isopropyl bound, but formally, according to IUPAC rules, that's not going to work. The way you do IUPAC rules is find the longest single chain in the molecule and go from there. So in other words, what's the longest chain? Well, 1, 2, 3, 4 is where I started mentally, and then I said there's an isopropyl. But if I keep going, then there's 5 and 6. So this is going to be a hexane of some variety because this is a straight chain with some branching, but it's 6-carbon chain. So this is going to be a hexane molecule. Now, what does it have bound? Well, as I've drawn it, as I've numbered it so far, there's a methyl at the 5 position and a chloro at the 4 position. But one of the things that you want to do beyond identifying it is figure out what the relative numbering of the molecule would be and the priorities. So chloro is going to be alphabetically sooner than methyl, so this is going to be a chloromethyl hexane. And then the other thing I want to pay attention to is that the numbering that I used there was arbitrary, but in fact the correct numbering here is going to be the other direction because you always want to have the lowest numbers. So the blue numbers here are going to end up being correct. That methyl is at the 2 position, the chloro is at the 3 position, and so on down the line. So in other words, this is going to be a hexane molecule that has a methyl and a chlorine bound. The methyl is at the 2 position, the chloro is at the 3 position. But the way you're going to write it up eventually is chloro first, so this is going to be a 3-chloro 2-methyl hexane. And that would be the final answer for the molecule. And that's how you do the nomenclature. So 3-chloro 2-methyl hexane. And if I were to draw it out the way you would probably draw it out normally, this is the way I'd do it. 3-chloro-2-methyl hexane. Now, I could go through many more examples, but the point is that you can learn how to do this. Again, it's algorithmic. Again, you can check yourself on any number of problems in the book, and this is not something I care about a great deal. So now I'm going to do something a bit more interesting, and that is, if we're looking at this molecule again, the key thing to recognize about this molecule is that it contains a benzene ring. And so you could say that the base case for this molecule is that it's a benzene, in which case you're going to start saying that we have 1, 2, 3 nitros and a methyl. Which one of those has priorities? Well, I'd probably call this a methyl benzene. So this would be a 1 position, 2 position, 3, 4 position, 5, 6 position. So this would be a 2, 4, 6 trinitromethylbenzene, which is one way of describing it. But a better way of describing this molecule would be not to call it a benzene, but instead to call it a toluene, which incorporates this methyl into it and inherently puts that at the 1 position. So this is going to be a toluene molecule, and the toluene puts the methyl at the 1 position. So this is inherently the 1, and then you can be arbitrary about which way you go around the ring, but we have nitros at the 2, 4, 6. So this is going to end up being 2, 4, S'21-trinitro-toluene, the molecule otherwise known as TNT. Key things to keep in mind when you're doing nomenclature would be to figure out what the base is, and what I'm illustrating with this molecule here is that you could call this a benzene with a methyl and some other stuff hanging off, or you could call it a toluene, and so on and so forth. So deciding what the base is actually becomes complicated once you have structures like this. In the case where you have straight chain molecules, then identifying the base means find the longest chain for getting the IUPAC nomenclature formally correct. And then after that, you basically have to figure out what the substituents are using your functional groups and so on and so forth. And then you have to decide where they go, and you're trying to find the lowest possible numbering, and you're using alphabetical for the naming. So you're going to have chloro before methyl. Doesn't matter what the numbers are, but you have to set the numbers overall blue rather than red, because this will have the lowest numbers for the substituents, 2 and 3 rather than 4 and 5. That's how you do the formalized IUPAC nomenclature.